All right, let's take a look at lesson number 3, the trig ratios. And I just want to remind you, if we are dealing with trigonometry on the Cartesian plane, we are used to right angle trig being opposite, adjacent, and hypotenuse. But the way we look at it in Math 30, because we're going to be going into all 4 quadrants, is if I have the point xy, the x value is this distance here, so that's why the adjacent side becomes x. The y value is this distance here, because that's how far it is up the y-axis. That becomes, opposite becomes y, and then our hypotenuse is our r value. So instead of using opposite, adjacent, and hypotenuse, we use x, y, and r. So sine becomes opposite over hypotenuse, which is y over r, and its reciprocal is r over y. Adjacent is x over r, and secant is r over x. Tan, opposite, is y, adjacent is x, and then cotangent is its reciprocal. And I know some of you might be wondering, well, why aren't you putting r as 1? The only time we indicate that r is 1 is if somewhere in the question it indicates it's on the unit circle. That's the only time r is 1. So I'm going to put a little note here. R is 1 on the unit circle only. So if it doesn't say so in the question, don't make that assumption. Another way to write the reciprocal trig ratios is to write it as 1 over cosecant 1 over sine, secant 1 over cos, and cotan is 1 over tan. So let's take a look here. Use the diagram below to express all the trigonometric ratios. Make sure you're really paying attention to what they're asking for, because primarily trig is going to be asking for angles or ratios. And when we're looking for ratios, we're basically looking for a fraction based on a triangle. So let's take a look. Use the diagram below to express all the trig ratios in terms of x, y, and r. All right, well, I'm going to take sine, opposite, adjacent, hypotenuse, and I know it is y over r, cos is x over r, tan is y over x, cosecant, r over y, secant, r over x, and cotangent, x over y. So that's just a little bit of a review of what we've done above. Now, the point -12, 15 lies on the terminal arm of angle theta in standard position. Write the 6 trig ratios for theta. This is a big question. These questions always get asked on assessments. So let's take a look at that. I know that this point where x is negative and y is positive, that's going to end up in quadrant 2. So I know this is my x value, and it's -12. This is my y value, and it's 15. But nowhere in the question does it say that it is on the unit circle. So we're going to have to calculate the r value. How are we going to do that? Well, we use c squared is equal to a squared plus b squared. But in this course, we generally say r squared is equal to x squared plus y squared. And I'm going to hit that, do the substitution. And I end up with r squared is equal to 369. And most often, and I'm just going to add it to the question, they're going to ask for you to express as exact values with a rationalized denominator. So we're going to handle that question this way. So what that means is I'm going to have to take the square root of both of these, and r is equal to square root of 369, which I believe is 9 times 41. So r is equal to 3 root 41 as a simplified radical. Now, they're asking for the 6 trigonometric ratios. So I'm going to start with sine of theta is equal to y over r. So sine theta is equal to, I'm just going to put the 3 root 41, and I'm going to take a look at it from here. Sine is equal to 15 over 3 root 41. And what we need to do is make sure that we rationalize that denominator. To do that, I multiply both top and bottom by root 41, and then I end up with sine theta is equal to 15 root 41 all over 123, and then I can go ahead and reduce the fraction. So I end up with 5 root 41 all over 41. So there's my first trigonometric ratio. Now I'm going to go ahead and do cosecant right now, since I did sine. So cosecant is equal to r over y. So cosecant is equal to 3 root 41 all over 15. So that reduces to root 41 over 5. All right, let's do cos. Pick a different color. Cos theta is equal to x over r, which is negative 12 over 3 root 41. And I'm going to do the same thing and multiply top and bottom by root 41. And that'll give me negative 12 root 41 all over 123, which reduces to negative 4 root 41 all over 41. So there's my ratio for cos. Now I will go do secant right away, which is r over x, which is 3 root 41 all over negative 12. And when we have a negative in the denominator, we either put it to the numerator or put it out front the fraction, whichever you're more comfortable with, and that will become negative root 41 over 4. And lastly, we're going to do tan, which is y over x, which is 15 over negative 12. So tan theta reduces to negative 5 over 4. And lastly, cotan theta is equal to x over y. So cotan theta is equal to negative 12 over 15. So cotan theta is equal to negative 4 over 5. And we've figured that question out. So again, just to reiterate, it's really important that when a question is looking for ratios, what you're actually producing is the fractions involved, not angles. So I'm going to let you go ahead and do class example number 1. I'm going to set it up for you a little bit. Number 1, it's talking, let me get rid of this, about this being on the unit circle. So we automatically know r is equal to 1. So the point B, negative 1/3 and 2 root 2 over 3, lies at the intersection of the unit circle and the terminal arm of an angle theta in standard position. I'm going to draw it for you, and I'm going to let you go ahead and do the values of all 6 trig ratios. Again, we have a quadrant 2 angle here because x is negative and y is positive. So my triangle is going to end up here. And I know this is x, this is y, this is r. Because it's on the unit circle, r is 1, and my x coordinate is negative 1/3, and my y coordinate is 2 root 2 over 3. So you can go ahead and finish that question, all 6 trigonometric ratios.